Hi everyone, my name is Sauvé and I'm a PhD candidate at Lancaster University, and I'm very happy to present our paper, Physecology, a conceptual framework to describe data physicalizations in their real-world context. So there's already a lot of work within the field of physicalization, ranging from static visualizations towards actuated systems, but also more artistic shapes, data sculptures, public installations, and so on. And all these works together show the wide range of physicalizations, highlighting their variety in context, audience, interactions, and more. So whereas these aspects are fundamental for the way we design physicalizations, these elements are currently not explicitly described. To give an example, if we take the physicalizations of econundrum and PhysiKit, we see they are used in different contexts, in a shared university workspace and at home. Hence, the audience is also different, a small community of co-workers versus a household. And looking at the interactions, the interaction with econundrum happens via entering personal data and a mobile app, whereas the visualization of PhysiKit is configured via tablet. So to be able to more fully describe physicalizations and their surroundings, we focused on answering the question, how to describe physicalizations in their real-world context. To discuss physicalizations in their surroundings, we introduced the term physicalization ecology or physicology, which describes the relations between the different design elements, physical and digital, of a physicalization and their coupling to the surroundings. So the physicology is a framework that considers the wider context surrounding physicalizations and unites it through 6 design dimensions. To give an example, the definition of physicalizations focuses on the physical depiction of data, so the actual physical artifact that represents the data. Whereas the physicology allows us to describe other surrounding elements such as complementary displays or devices that allow for interaction, and the different audiences that it can have. We analyzed 60 representative samples and derived 6 design dimensions of a physicology. For a detailed overview of how the 60 systems are represented in the dimensions, I would like to refer you to our paper, but in this presentation I will highlight how exemplar systems fit in the different dimensions. So first of all, data type, which is about what info is represented. We observed that physicalizations can have different topics, such as more personal data, community data, or environmental data. Then the availability of data is static when it's a fixed data set, such as activity sculptures and tidy street, or dynamic, such as the weather feed of Tempscope. And lastly, different attributes can be visualized. So Tempscope shows categorical data through different weather conditions, whereas the other 2 examples show quantitative data of physical activity and energy usage. Information communication focuses on how the information is represented. More than half of the samples involved some form of positioning in space to communicate changes in the data. For example, linear bottom-up motion or top-down motion, but also circular movement. Moreover, we observed control over optical properties, for example through the use of LEDs, as you can see in Emerge and econundrum. And then there were other examples that involve specialized applications, such as chalk spray, or the control over material properties, or even other modalities. Interaction mechanisms describes how the information is changed or how it can be interacted with. So this dimension is twofold. So on one hand, you have the interaction directness, so whether or not a physicalization is interacted with at all, and implication, which is what actually happens to the data once the physicalization is interacted with. First of all, installations and data sculptures often involve no interaction at all. Relief is an example of indirect interaction by hovering the hands to explore the data. In contrast, Coda allows for both direct and indirect interaction, not only for the exploration, but also the configuration of the setup. And EdiPulse is an example of implicit indirect manipulation, as the user might not be aware that their physical activity is input for the 3D printed visualization. Spatial coupling describes the spatial mapping between the user and the physicology. If it's a full coupling, the output device is the input device, so the user can directly interact with the physicalization. If it's nearby, the output takes place near the input object, so the user can perform explicit but indirect interactions. However, if it's environmental, the output is around the user, in the surroundings of the physicalization. So in the example of PhysiKit, the household can use a tablet to make changes to the visualization, and then they can put the cubes wherever they want in their home. And if it's distant, the output is over there, on another screen, or even another location. So distant coupling can be distant in space, but also in time. In the example of visualizing Mill Road, the interaction happened inside the shops, and the visualization was actually created a day later outside of these shops. Then the physical setup, which describes how the physicology functions as a whole. If it's a standalone physicalization, there's no other physical or digital elements involved. If there's a spatial distribution, it means there are additional co-located components to extend the visualization or to provide extra information, such as an additional display. And if there's a logical distribution, it means that there are additional components to allow for the interaction with the physicalization. And finally, the audience, which describes who is interacting in what way with the physicology. Generally, we observed three contexts of use: private, such as the home; semi-public, such as an office space, university building, or in this example, a conference; and public, such as a museum or an outside square. And across these different contexts, we observe two different types of audiences. So the users are the ones who directly interact and engage with the system, whereas the spectators are the ones that merely observe. We can use the design dimensions of the physicology to understand how physicalizations position themselves within a design space and in relation to each other, but also how the dimensions relate to each other. For example, direct interaction correlates with a full coupling, whereas indirect or no interaction relates with a more environmental or distant coupling to the audience. The relation between the physicalization and the physicology it belongs to is also further illustrated in this diagram. If we take the two examples from before, we can now dissect them and understand how the different physical and digital elements relate to each other and how it interacts with the audience. So we see that for emerge, the bubbles for information communication, interaction, and setup strongly overlap, which leads to a nearby to full coupling. Whereas for econundrum, there's more disconnection between the bubbles, which leads to a more environmental coupling. Finally, I would like to share some main takeaways of our work. So we propose Physecology as a framework to describe a wide variety of physicalizations, understand the relations between digital and physical elements within and surrounding physicalizations, to use the dimensions to shift between low-level and high-level challenges of physicalization research, so we can further unpack the different mechanisms that constitute a physicalization, and guide future designs of physicalizations so that we can become more strategic about the design of physicalizations for real-world use. And with this, I would like to thank you for your attention, and in case of any questions, feel free to contact us.